Hello, everyone. Thanks for coming. I'd like to start from stating my goals, and then I'll present ourselves. I have two goals for this presentation. The first one is to ensure that we understand what is the right architecture to set up high availability solutions on Azure. And the second one is to get you to the party on time, to get you to the theme park on time. So we'll try to be brief, but we'll deliver the content. So I'm Igal Figlin. I work for Azure Compute, and I'm a product manager for VM platform. Essentially, our team is dealing with everything that has to do with VM uptime, reliability, performance, and so on. With me is Ziv.
Ziv Rafalovic, good afternoon. Another PM in the Azure Compute team focusing on availability.
Dave Buse from Adobe, and at Adobe I'm a cloud architect, and I help teams within Adobe deploy their solutions onto Azure.
Jayan from Adobe. I work as a cloud engineer in the AEM managed services team. We run AEM as a managed service.
Thank you for joining us. So we'll start first from talking about VM resiliency. What does it take to run a single VM in relatively good availability, good experience on Azure? And then we'll talk about the real high availability architectures. We'll talk about what could be done, types of things you could configure. And finally, we will look into Adobe architecture and learn from the best. So let's start. So let me first define the problem space. When we are talking about high availability, in many cases, we just look into one aspect, but there are actually three aspects we need to consider for business continuity. High availability, and this is essentially ensuring that your application is always up, is just one of the aspects. You may want to architect your application in such a way that it spans multiple fault domains. There's no single point of failure. Even if a specific component of the application fails, your customers are not observing any kind of failure. The second aspect is disaster recovery. From that perspective, you may want to ensure that you're prepared for any kind of environmental or man-made disasters, essentially when entire region could go down. Think about tsunami or earthquake or even some deployments that gone wrong, man-made disaster. So definitely you want to prepare for disaster recovery, and in many cases you might want to consider different solutions because of how far your disaster recovery region is from your original deployment location. And the last one is backup. Backup definitely has to do with disaster recovery, and in some cases people confuse between those, but backup is also ability to get back in time, and in case something got wrong, be able to restore the data, restore the state that was there before something got wrong. So this is overall spectrum of solutions we need to consider, and in this spectrum of solutions, we are looking into 4 different levels of availability and resiliency. And let me first present the overall space, and later on we'll go into specific details. And I'm going to focus just on what single VM. I'll start from single VM, and then we'll talk about availability sets, scale sets, and multiple regions. So for single VM perspective, we are offering SLA of 3 nines. However, what does this mean? If you have just a single VM and your software component fails, that's what it is. So we definitely need to prepare for configuration where multiple VMs are running, but nevertheless, we definitely want to ensure that this single VM gets as much availability, as much uptime as possible, and it behaves in the best possible way. We are offering SLA when the single instance VM is paired with premium storage, and this is pretty much the only requirement. But once again, think about it. When you are updating your OS on that single VM, your application is down. So very hard to call this highly available solution. It's a solution which we want to optimize for. The second one is multiple VMs running in a single DC, in a single data center. From your perspective, what you are defining is availability set or scale set running within a region. And in many cases, those will be protected against single hardware piece failure, like rack or physical machine failure, network cabling failure, power supply failure, but they won't be protected from region-wide AC outage. Regional availability, this yet another step. This will allow us to be protected against entire region going down. Think about chiller, think air conditioning unit, or think about some generator, power failure and generator going down at the same time. This kind of scenario requires us to deploy in multiple data centers, even if they're close by, but multiple data centers that provide resiliency against this critical data center environment failures. And the last one, when we're talking about global scale, you might want to consider protecting against any kind of natural disaster, but also you might want to take into account what are the data jurisdiction boundaries you are required to observe. For example, some of our customers are required to keep their data within a certain geographical boundary and not move it beyond that, so you may want to consider that point when setting up regional data resiliency architecture. I think that's it. The last item I wanted to mention is that SLA goes up from 3 nines to 4 nines, but definitely this is not where we stop. And I'll talk a little bit in a moment about how we measure SLA and what was the change that we did last year in order to get better. So I'll start with a basic VM availability. Our internal goal was to get to 5 nines for every single VM. And we are pretty much there, but this is not enough. Even if we're at the 5 nines, your VMs will experience 26 seconds of downtime per month. This is just 5 nines bar. This is not enough. One reboot for every VM, and you are at quick reboot, and you're at 5 nines. This is not the experience we want to achieve. And so we thought it doesn't make sense. We see a lot of our customers, we see a lot of the consulting companies looking into this availability SLA. This is not enough. We really need to get to a point of 0 interruptions. And you know what? Not all the interruptions made equal. There could be networking interruptions, there could be some kind of CPU pauses, IO pauses, IO blips. So we would like to count interruptions. And what we did within the last year, we switched entirely from looking into the SLA and average SLA numbers to count of interruptions per customer. We decided to call this number air, how conveniently. We would like to make sure that the air quality for our customers is as good as it can be, and identify air pollution when we attempt to deploy new components or implement new changes for the platform. And so, essentially, if I'm to describe this component, it's what is the rate of interruptions per VM per year? That's basically an air. It's 1 divided by mean time to failure, if you're thinking really hard about this, but the good news about air by itself, it's easy to average it, and it's easy to add components to it. So for example, if I'm looking into specific applications that Azure runs, I can see that infrastructure contributes certain type of air, and maybe application contributes the rest. So us moving to this concept allows us to target much more explicitly the interruptions, the points of time where customer is not getting the perfect experience, even if the pause is super, super short. And so we see a lot of those short pauses, and we decided to go after annual interruption rates. So we definitely got better at this, and definitely there's much more to go. We are, at this point of time, looking at improvement of 6x from where we are today just by the end of this year, just because we started looking into this number. We did separate between AIR, what we called AIR-R, annual interruption rates of reboots, and AIR, it's silly, AIR-BP, AIR due to blips and pauses. And we are explicitly measuring each one of those. But once you start focusing on this, once you are able to measure them for your application, in my case, this is for Azure application, we are definitely seeing the trajectory, teams are focused on improving it, and so on. I show here in the bottom of the slide this journey that we had since we kind of started end of 2014 focusing on availability until today. And I think just last year when it was clearly 5 nines and we felt it's not good enough for us and we really need to go to after the air quality. And so this was kind of mindset shift for us, big mindset shift within Microsoft, and this is where we are heading right now. And by the way, when we talk about air, it includes everything. any kind of interruption, planned, unplanned, whatever. As long as your customer, your end customer, is able to observe some kind of blip, that's an air pollution. Let's go back to terminology for a moment. So there are more than this, but just so that we have the same terminology, 3 types of events. First one is unexpected and unpredicted downtime. This is the worst. This is the system got some kind of failure, and we couldn't predict it. We didn't know that it will fail. My goal, of course, is to minimize the amount of occurrences where this can happen. And there are a bunch of techniques, definitely improving the hardware, definitely improving the quality of the software, identifying the failure rates as they go up, and so on. But there's a bunch of things that we can do here, and you can protect yourself against this by architecting your application correctly. We'll talk about it in a moment. The second one is what we call unplanned hardware maintenance event. So this is more interesting. We can predict the hardware is going to go bad, but it didn't go bad yet, or didn't entirely go bad yet. In this case, we would like to make sure that customer application, customer VM is not impacted. So we will attempt to live migrate the VM when possible. By the way, not always possible. Imagine a case where your VM is running on half-degraded disk with half of the I/O speed. It might be that it's impossible to live migrate. But if it's possible, we'll attempt to live migrate. If it's not possible, we would like to give you a heads up, and this is one new functionality that is coming later in the next couple of months. We'd like to give you a heads up that we tried to live migrate you. We could not. Heads up, you might want to redeploy your VM. It's still running, just so you know. Or if you don't do anything, we'll redeploy it, but you can, of course, coordinate and decide to redeploy it in your time. And so our thinking was that we will allow something around maybe 2 weeks for that. And if within those 2 weeks we don't see any input from customer, we'll just go and redeploy it to the well-behaving hardware. So the last one is planned maintenance events. This is the absolute worst. There's no such thing as planned maintenance. It should be 0. And this is what we are after. We are after making sure that every time we have any kind of maintenance events, you guys don't know about it. So my success is that you guys don't know about our planned maintenance. Unfortunately, we are not in perfect world, and I'm not sure how perfect the world would be even in the best possible situation. And so we are working on making the planned maintenance as transparent as possible. I'll talk about what we did and how we mitigated the latest threats that we identified, but planned maintenance still type of downtimes that might occur. And by the way, when I say downtime, it's not necessarily reboot. It could be just a pause in I/O. Short pause in I/O, from my perspective, is an impact that I'd like to eradicate for Azure. So how the update mechanisms work? I'll start first from the planned maintenance. We just talked about maintenance. Let's double click on this. What we are doing in our platform, we are attempting to update everything with really 0 impact. And there's a huge amount of mechanisms we have to update the platform with 0 impact. In some cases, it's not possible. We will attempt to implement in-place migration, in-place update when it's possible. Essentially, we will replace the underlying operating system on the node or operating system, replace underlying configuration settings in order to get you to the latest possible version or security mitigation and so on. So the idea is, and I'll talk more about in-place updates, but the idea is if we cannot do it with 0 impact, find the best mechanisms with minimal impact. If we cannot do this, due to whatever reason, think about replacing power supplies. This doesn't sound like something that can be done safely with in-place update. We might live migrate you to a separate machine, to a different machine, have you there while we are replacing power supplies on the first machine. Some of the customers don't like even those impact from live migration or from in-place updates. For those customers, we can offer self-maintenance window every time we have this type of impact. I just want to share with you an update, and this is pretty recent, and I'm super excited about it. But we had pretty bad time in the beginning of this year when we had unexpected meltdown and Spectre issues hitting upon Azure, and some of the customers observed reboots for their environment. We just had another vulnerability like that, which was published on August 14, if I'm not mistaken, L1TF, foreshadow, more commonly used. And we did it with the new mechanisms. It all worked. No reboots, short pause. Some customers observed 0 pause. Some customers observed, on average, 13-second pause. But bottom line, it all worked without customer impact. So I'm super happy. This was hard effort for us, but I hope that it's worth it for our customers. I'm getting a lot of confusion about what those migration means and how do I configure my VM. And why does it matter to me? Why am I telling you all of that? Fix your system, fix your stuff, don't tell us about it. I think it does matter, and we'll talk in a moment about what can you do in your application to protect yourself, even when the impact is super minor. But let's first understand 2 types of updates, 2 types of changes that you might observe. In-place migration is when we essentially update or get our system more secure, and we update the node underneath without touching your application, just with a short, brief pause to the VM. In some cases, there's not even a pause to the VM. It's super quick. It doesn't move you to a different machine. It's just an in-place update, and we have a bunch of mechanisms for different types of components that are running on the machine. If I'm just to run an animation, how it looks like, you have 2 nodes, node A and node B. And after the update, both of the nodes are updated, and both of the VMs went from red unsecure to green secure. So super clear. Live migration is moving you to another machine. It's definitely a slower mechanism because there needs to be a coordination across empty space. And this is definitely a mechanism that is quick, but not as quick as in-place migration. So in Azure, we are definitely focused on making in-place migration as effective as possible. But we do need to have, and we have live migration for cases where in-place migration is just not enough. And so just to give you a feeling, same node A and node B, if we are going to update node B, we are moving everyone to node A. I just skipped multiple steps here, but eventually everyone will land on one updated node instead of just updating the nodes underneath. So we might land them on node B, update node A, and move them back to node A after it was updated. The latest impact, just to get a feeling, what does it mean? You have been live migrated. We are observing averages of 1.7 seconds for premium storage blackout times and 2.8 seconds for standard storage. But this is kind of a ballpark of what you should expect for impact. If your application is able to sustain those pauses, you are golden, and essentially this whole thing goes completely transparent for you. If you are not, or if you want to prepare for some different cases, there are mechanisms. And we are looking into those mechanisms as kind of an evolution of what we are doing with plant maintenance. So first of all, we are looking into impact reduction. And I talked a lot about it with all different types of mechanisms, but we also are looking to provide more control. We would like to give you control about, even if it's planned, when exactly does it happen. Ziv in a moment will demonstrate, in a couple of moments, scheduled events. This is a mechanism, metadata that you can read locally from your VM, some kind of local IP address you can read, and you suddenly get back the maintenance information. But bottom line, if you poll this interface, you can understand in advance that we are going to take this action. Once again, when we are going to take this action, when we can identify pending hardware failure, or we are required to do some kind of maintenance, for example, security purposes, right? We definitely are getting better on communications, and if we think that impact is more than what we expect it to be, we will communicate it with you. We recently revamped some of our communication mechanisms. We heard that not all the communications are reaching intended audiences. We are getting better with that. Anything I'm missing, Ziv? No, okay, I'm good. Okay, cool. I want to share with you one another thing that it's pretty cool. I don't have much time here. Maybe next year we'll do a bigger session on this, but I'm super excited about this. And this is essentially changing how we approach Azure management overall, and why you are suddenly seeing more and more proactive healing. So we started thinking about how do we manage our infrastructure? how do we make our infrastructure management, make less mistakes managing our infrastructure? And one of the big investments we started to make are around prediction, machine learning, and this is like marketing name. How Azure is minimizing downtime with Azure Artificial Intelligence. But bottom line, we are gathering the data about behavior of our platform, and we are letting our machines to take actions instead of operators. And we are more and more relying on machines, and in more and more cases where data we have is soft, and we are essentially optimizing for the best possible case rather than black and white management. Should we vacate this machine or not? I don't know. Chances are yes. Okay. So we defined some 3 principles for us for machine learning. So first of all, we would like machine to be able to take action, predict, understand what's going on, and avoid failures. And when needed, move the customers away from failing components. Super important if you're just running single VM, but not only. We want to make sure that the system can take actions. Actionability is super important. Everything we can predict has to be wired into a system and take actions. Once again, from your perspective, the visibility are VMs, but not only. Bottom line, we would like to proactively adjust and avoid the failures. And the last one is human interactions. So the principle we defined is that machines need to call humans when needed. When it fails, it needs to call human. And when it calls human, it's better give what it thinks what's happening in the system, even if it's not conclusive. For example, we are focusing on providing some initial kind of root cause analysis when human is first engaged. Definitely this is important in case of outages and scale, but it's also important for even specific VMs. And so it's not just low human intervention, it's also a question of how quickly we can call this human. And by the way, if we think that something is going to go wrong, but it's all cool right now, but it's going to go wrong, and system doesn't know what to do, fine, engage the human. Better engage human before something wrong happens, right? Cool. I'll just talk about one thing that we did recently. It was many systems. This one we published in a paper, so I can talk about it. But there are many more that we worked on and have. But just this one is an example. This is a disk failure prediction. So we have a set of mechanisms that allow us to create a model on how disks fail in production environment, predict those failures, and take action before those disks actually fail. There's some explanation here. We first do a training, some internal names. Then we live migrate the machines. But I think the bottom line is it's better to take live migration than to have a VM crashing due to failing disk. And our goal is to have this mitigation action as simple and as transparent as possible. Cool. I promised you scheduled events. Who knows what scheduled events are? Okay. Let me go into the details. So scheduled events is kind of your window into the future. Talked about machine learning, I talked about prediction, I talked about planned maintenance. This is your window into the future. So there is an interface you can access that provides you information about what is going to happen with your VM in the next 10, 15 minutes, up to 15 minutes. And there's a format here, Ziv will show in a moment demo, but the idea is you use this REST API. If there is an event pending, you are able to either take an action or just ignore it and let system run due its course. Event pending could be live migration with 1.7 seconds impact on average. You probably, in most cases, I hope you don't care. But it also could be a reboot pending because there's nothing we can do and we will need to reboot your VM. The hardware is degraded to such a degree that only reboot can help. By the way, those events appear also when we are trying to, when you are trying to manage your VM. For example, when you are managing your VM and rebooting it or redeploying it, scheduled event will also appear and your application can consume it. So you can wire your application in such a way that it will react to availability events before those occur. Last point I want to make on this before I go to what's new is that from your application case, you can decide on failover. You can decide to spin up a new VM that will do some work, or you can decide to do nothing. But you can create mechanisms. And we have some samples in GitHub where you can start from them. You don't need to invent the wheel and write all the code, but you can essentially start from a point where your application is already future aware. So some new items that we added there. last slide before the demo. Some items that we added there, we now can decide whether user events or user configuration triggers scheduled events or not. If it does, if you decide to configure it as not triggering, then you will only get events on platform events and not on user changes. And of course, if you are deploying something like that, you can test it. If you are using full-size VMs, and we have something called, we have VMs called D15, V1 and V2, and E64. If you are using those, you will get slightly more times than 15 minutes, and we are working on providing some more flexible configuration for larger VMs. But bottom line, you are at least 10-15 minutes. If we are able to provide it, if we are able to wait and machine is not degrading, you are going to get the heads up with scheduled events. Ziv, take us through demo.
Right. So, as Igal mentioned, we have deployed scheduled events last year, and we started collecting feedback from customers. So one was actually to opt out from the user-initiated operations, which we thought is a great way to actually test your logic. The second, as he mentioned, there are some applications consuming the entire host, like large in-memory databases, and they need more time in order to be able to proactively failover or save state, drain the state to a disk, and something like that. But another common feedback was, hey, you know what? I do like this notification, but I need it outside of my VM, okay? So the goal is to be able to get these scheduled events and be able to trigger any specific logic that you may want to take. So we are going to demo now an extension sorry, which we built, which picks those scheduled events and put them on Event Grid. Event Grid is one of our cloud messaging services which has built-in connectivity into Azure Functions and Logic Apps. So you can write serverless code, which I will demo soon, to handle those scheduled events. Use cases could be to turn on a standby server, to take the machine out of the load balancer, or even to notify an admin, if that's a critical asset. So the sample I'm going to show is a starting point. It's not a baked feature, but this is something that we are working on. Eventually will be a feature of the platform, but in the meantime, let's switch to the sample. So first, we have packaged this extension.
Wait, it's switching.
8. Thank you. We have packaged this extension using custom VM extensions. So you can take it and apply it to existing VMs. You don't need to go and redeploy your VMs. Then the logic itself, the extension itself, is very simple. I go, pick, come on. I go, pick a scheduled event. If there are no events, then do nothing. Else, I go and send this event to the event grid so I can pick it up from my logic app or function. Also, one of the config settings here called AutoAC. We have the ability to acknowledge the scheduled event. By acknowledging the scheduled event, we basically tell Azure, I'm done, you can go ahead. Now my VM is just sitting idle. Go ahead, don't wait the 15 minutes. So one of the settings is whether to acknowledge the event or not. Okay? Now, in this sample, I have connected this event grid to a logic app. Logic apps is one of the two serverless offers. The other is function. The beauty of logic app is that it is code-free. By the way, you can combine logic app and functions and call your function from the logic app to simplify complex tasks. But logic app is great for orchestration and using one of the many, many built-in connectors. In this case, I pick up the scheduled event, I write it to a blob storage, and also I send an email notification with the built-in connector. Okay? So what I'm going to do, I'm going to run my extension in an interactive mode. Okay? It is usually run in the background as a service, as a Linux daemon. But this case, I'm running it in an interactive mode, and you can see, no scheduled events. I put a very high polling frequency, so we can see the events every 2-3 seconds. And while this runs, I will go and initiate a reboot to my VM. As I mentioned, one of the capabilities of scheduled events is that it will pick up also the user-initiated operations. It's a great way to showcase and test your logic. So I am currently going to restart my VM, hope to see a scheduled event being picked up, an event being sent to Event Grid, and eventually an email being sent to my inbox. Okay, here we go. I asked Azure to restart the virtual machine. You can see Portal is still looking, Azure is looking for the VM. The message was sent, the event was caught, and if I go quickly to my inbox, I will hit refresh, and I see that I got the email. Okay? So it all took like, less than 10 seconds. So I got an email saying, and I just put the subject of the message. I didn't put all the rest of the content. But what I see here is that the event type is a reboot because I asked to restart the VM. The host name, and a not before. That's the 15 minutes timestamp. Now again, since I believe I have set it to auto-acknowledgement, I believe my VM has already, I lost connectivity to the VM because it already rebooted. So just to recap, I restarted my VM. Azure sent me a scheduled event. Again, kind of a mimic of a platform-initiated event. I picked this one up, sent a message to Event Grid, and also told Azure I'm ready. I picked the event from my logic app and sent it as an email to the admin, in this case, me. All right, the code is available, written in Python, very easy to understand. Okay. So we talked about VM resiliency and what we do in order to improve the air quality. Let's talk about high availability. And in essence, high availability is all about having multiple instances of your resource, being a VM, with some sort of a fault isolation promise. Okay, so looking at this spectrum of options, you can either do your high availability within a single data center, within a single region, or go global. And basically, the broader your blast radius is, the broader, the more distance you have between your VMs, you're better. But unfortunately, geography and the speed of light both results in latency. So whether you go global across data centers in the same region or within a data center in one region really depends on the latency requirements. Just to recap, within a data center, you can use availability sets or VM scale set to spread your VMs across fault domains. Within a region and across availability zones, you can use either single VMs or VM scale set. Basically, with single VMs, I deploy VM1 to zone 1, VM2 to zone 2, and I'm good. And across regions, those are multiple different deployments. Combining the need for some sort of high availability, we ended up with this, we call it poor man's high availability. I call it the dentist scenario. So my dentist, although he charged me a lot, he doesn't have the need for multiple VMs, but they do want some sort of high availability. Now, in this case, what we have done is we put together scheduled events and creating two VMs in an availability set, powering off one of them, turning off. So when we pick a scheduled event from the primary one, we still have 15 minutes. This is sufficient time to go and redeploy the backup or the standby VM so I can move the traffic to my standby before the 15 minutes over. Again, this is not something which is robust. It's more of a proof of concept in a way, but may help if you have a legacy app which cannot work in an active-active architecture, or your business requirements do not justify running multiple VMs, and you still want some improved resiliency from a single instance VM. The same logic could be applied. One of the other features we've rolled out is resource health alerts. So you can get an alert when your resource is down. You can wire this alert to whatever logic you have to bring up your backup VM. Now let's talk about real high availability. And we'll start with the basics. So when we launched Azure or infrastructure as a service early on, we rolled out something we called availability sets. And the concept was that you have a single deployment which spans fault isolation boundaries. We call those fault domains. In reality, those are mapped to racks. Now, this is logical fault domains, meaning that the only promise you get is anti-collocation. Meaning that if you have two VMs in fault domain 0 and fault domain 1, those will be in different racks. If you have 20 VMs, 10 in fault domain 0, it doesn't mean that those 10 actually are within the same rack. Okay? Also, availability set is not a co-location constraint. Historically, with smaller deployments, smaller data centers, you could assume that if you deploy an availability set, I'll get a very good latency between my VMs. But it may not be the case going forward. Keep that in mind. And hope to update you later on this year on the co-location front. Earlier this year, we also rolled out the notion of aligning the compute fault isolation domains with storage fault isolation domains. Remember that your VMs actually boot and operate from remote storage. If you have two VMs which happen to be served from two disks which happen to be within the same storage stamp, you are at risk. So what we've done is we decided early on to align the compute fault isolation with the storage fault isolation. In other words, if you have two fault domains, this means that disks for VMs from those two fault domains are actually served from two separate storage stamps, okay, within the same region and the same zone. So with availability set, you get fault isolation for both compute and storage within the data center. VM scale sets were launched somewhere last year, and they operate based on the same assumptions with several caveats. They can scale better. So if you want to achieve the same fault isolation promise for your VM scale sets, keep in mind that you need to disable the VM scale set scaling. They have a checkbox when you say, I want to scale to more than 100 instances, so you need to uncheck this one. Low priority scale sets do not support any sorts of high availability. And also, coming really, really soon, we will align the storage fault domains with the compute fault domains for VM scale sets. This is coming really soon. Okay. Before we talk about availability zone, let's talk about some motivation. This is the weather forecast, September 3rd, 4th, and 4th, from San Antonio. Okay? You can see they had 4 seasons in one day. It started with a temperature drop of 23 degrees Fahrenheit, followed by fog, rain, thunderstorms, and sun again. Okay? The hero in this story are the data center chillers. These are those massive facilities just outside the data center itself, which are supposed to cool down water to keep our data center in working temperatures. So, as a result of those thunderstorms, we ended up with power sags and swells. And as a precaution, we cut the utility power and started running on generators. This all works as well, works perfect. Our data centers are built with what we call 5 nines availability. The data center was built to handle with that. Then, within 30 minutes, another event in another part of the region, another data center. Okay, same thing. However, one of the aspects in those chillers was the option to turn on the backup power, which was a manual step. There are several reasons for that. One is that it is really hard to identify the root cause of this power failover. Hence, the data center team decided to test new capabilities, new devices, and for the time being, those were manual. Now, in the storm of those two events, and the second one resulted in something like 1,200 alerts, the DC Ops failed to triage the indication. Too many lights went on. So they failed to switch the chiller to backup power. As a result, within a short time, temperatures started to rise. And when we sensed that the temperature is getting to a dangerous point, we started a graceful shutdown of our servers. Soon enough, the data center ops team realized their mistake, turned on the chiller, temperature started going down. At this time, we looked at the storage stamps and realized that we can recover all of them. Now, since our storage disaster recovery plan uses asynchronous copy to a different region, when failing over to a different region, we may lose data. And as long as we know that we can recover all of the data, we will try to recover it rather than fail over. By the way, one of the lessons learned, and I'm happy to announce that soon enough, we will give you the customer, the control to decide when to fail over. In other words, if you create a storage account, a GRS or GRS, then you will have the control over when to fail over, whether to wait for us or act faster. One of the services, so far, data center, DC Ops has nothing to do with you. It's a nice story to tell. Let's continue the story. One of the services deployed in San Antonio was ASM, Azure Service Manager, also known as the classic VMs or RDFE. So for you customers, I hope none of you uses classic VMs, but unfortunately, some of our core services still use PaaS cloud services, hence had a dependency on ASM. Okay? ASM by itself is a global service, has 2 deployments in the US, and ASM by itself failed over to their failover region. One of those services which was dependent on ASM in San Antonio was Azure AD, which is used by many other services. So Azure AD, again, being a global service, failed over to another region in East US. Unfortunately, the failover site, East US, had a dependency on the same ASM deployment in San Antonio, meaning AD in San Antonio failed over to multiple regions. One of them actually had dependency on the same ASM. So it's not a circular dependency, but it's a chain of dependencies. This is something I want you to take. When you look at your resiliency, okay, walk the chain of dependencies, okay? Circular dependencies are easy to find, but build this dependency graph, all of your services, AD, data centers, application servers, gateways, application gateways, monitoring, control systems, okay? Make sure that your dependency graphs has no circular dependencies. So, as a result, the failover of AD got stuck in some regions, creating additional load on the rest of the Azure AD regions. Another issue was caused due to one of the other services in Office, which basically, when they lost connectivity to Azure AD, they kept retrying constantly without any back-off logic, meaning they create even more load, ended up throttling our service. Okay, so we throttle our clients to make sure that one customer does not take down the entire service. The takeaway for you guys is when you design your failover logic, make sure that whenever you do retry, you never continuously retry. Okay, so you need some back-off logic. There are many, many patterns by Microsoft and others. Make sure to avoid this continuous retry logic. All right, so that was an excellent wake-up call for us. Okay, and there are many, many activities that the team has committed to take forward. All right, for you as customers, this actually should bring up the importance of considering availability zones. So we announced availability zones last year in preview. Now we've added more regions. But in essence, availability zones help you protecting against data center level failures. In other words, the way we carve zones in a region, we pick different data centers with independent powertrain, network, and cooling to make sure that there is no facility level incident like San Antonio, which will take down multiple zones. So in a way, the fault domain boundary is now a data center. Okay? The downside of availability zones, beside the fact that it is very expensive for us to retrofit our fleet, the downside is that latency is not as good as it could be within a single data center, because you need to take several extra hops out of the data center into a regional networking facility, going back to another data center, and so on. The promise that we have is basically to have a VM-to-VM round trip of 2 milliseconds while within a region, in an inter-zone deployment. If your application cannot sustain a 2 millisecond round trip, then you probably cannot deploy it across 2 zones. You need to think of something else. But in general, and by the way, this is compared with the public statement of 1 millisecond when you are within a single zone. And we will make additional announcements later on this year when it comes to extra sensitive applications which need even lower latency than 1 millisecond. Stay tuned. So when thinking of zones, you have basically 2 options. Either go and do zonal services. I mentioned this. You take a VM, you put it in zone A. You take another VM and put it in zone B. The managed disk will come from the same zone. If you're using storage accounts, then you don't get it. And you can also go and create virtual machine scale sets. 2 scale sets, one in zone 1 and one in zone 2. This is the zonal approach. The other approach is zone redundant service. And as you can see, we are working to have our core services becoming zone redundant. Core servicing is like storage with ZRS, zone redundant storage, like SQL, like the networking capabilities, the load balancers, the VPN gateways, and application gateways, and messaging services like Service Bus and Event Hubs. So expect more core Azure services to become zone redundant, because we have learned the lesson. Deploying resources in an AZ is as simple as adding the additional parameter to a virtual machine. On the left, you specify zone 1. The managed disk in the middle specifies zone 1, or even your VIP, virtual IP. Going to zone redundant services is very similar. In a scale set, you specify the array of zones. For Azure, you specify the zone redundant flag. Sorry, for SQL, Azure DB, you specify the zone redundant flag. And for load balancer, you specify a standard SKU. So standard load balancer may span zones, while basic load balancer will not. So trying to summarize all of your high availability strategies or high availability options. If you can go global, meaning and the key question is how do you replicate your data? You may go and put your data in a global repository like Cosmos DB. Okay, Cosmos DB enable you to define multi-master and you get global spread of your span of your data. If you can do that, all for the best. Otherwise, if you can replicate your data across regions, either due to a low write kind of frequency or you're okay with the latency, go ahead, deploy resources deploy resources globally, use Traffic Manager, and you're covered. Otherwise, consider using availability zones when you can. In other words, in going back to the regions with zones, okay, if you deploy in US or in Europe, okay, the two larger regions in Europe, North and West Europe, or Southeast Asia, you're good. If you are not, consider picking those regions first. Now, if your customers are in Australia and everything is in Australia, apologize, not yet. But if in the US, think about the zonal support and pick those regions with zonal support. And again, more to come. I cannot disclose at this time. The other limitation I mentioned to use zonal deployment will be latency. Again, if your data replication requires less than 1 millisecond latency, don't spread zones. Okay? You won't get the latency that you need. Otherwise, use full domains, use availability sets with full domains. That's the best you can get. Another aspect from this San Antonio experiment was test your readiness, okay? AKA Chaos Monkeys. Now, although we do not have a Chaos Monkey service, there are several tools, utilities, projects. You can just search Azure Chaos and you'll find several utilities. But consider the following aspects of your Chaos. One is to mimic power loss impacting VMs. Okay? Take down one VM, all of the VMs in a full domain, all of the VMs in an availability zone, all of the VMs in a region to simulate different aspects of chaos. Another aspect is network. So take network security groups, NSGs, and apply NSGs to block everything on a subnet or on a NIC, okay, to simulate split brain or network disconnect, okay? We often hear customers say, yes, I practice zone AZ failover. Like, AZ failover is your decision. You decided to failover to another AZ. AZs do not go down. It's not a Boolean state, AZ up, AZ down, okay? AZ going down, even with San Antonio, is a chain of events. It's really hard to pinpoint when failover should happen. But when you practice chaos, think of different aspects of network disconnect. One of those tools that we recommend, written by one of ours, is Azure FI, Azure Fault Injection. You pick the subscription and resource group, and you specify the duration and what sorts of failures you want to get. This is like a web app. The result is a blob storage, and with a bunch of Azure functions, they trigger those failures.
So I think the bottom line is try all your failure scenarios. Hopefully your production environment can sustain those, but definitely in your test environment. I think we are mostly done with the high availability part.
Sure.
And, let's welcome David and
Jayan.
Jayan from Adobe to tell us a little bit more about what they did to keep Adobe up. Thank you. Thank you for joining us.
You're welcome.
Thank you, Ziv. Thank you, Ziv. Thank you, Igal. We appreciate the opportunity to take a few minutes with you today. So why are these two yahoos on the stage here, with these guys? We're here representing Adobe, and what we wanted, our goal is to just take a few minutes and share with you a couple of the patterns that we're using in Adobe to provide production workloads for our customers in Azure using availability zones. Now, a lot of this started, if you go back 2 years ago at Ignite, you had Shantanu, which is our CEO, and Satya, the CEO of Microsoft, up on the stage at Ignite announcing the partnership between Microsoft and Adobe. And as part of that partnership, Adobe is deploying or hosting the solutions they provide for their customers to provide their customer experiences on Azure. As a part of that customer experience, it's essential that we have availability. As a part of that availability, when we look at our SLAs, it was important for us to be able to use the availability zones, which were just recently released, announced in preview late last fall, and then announced for general availability just a few months ago, in late spring. And we've been working with Microsoft on these solutions for quite some time. Now, in our case, we found that one size does not fit all from a high availability standpoint. And what Jan and I would like to share with you is a couple of contrasting solutions that Adobe has implemented on Azure that are in production that use availability zones, but in very different ways. We're going to look at Adobe Experience Manager and Adobe Sign. One of those solutions is a single tenant solution that we deploy for customers and manage for them. And the other solution is a multi-tenant solution that we have multiple customers all using the same environment, and we scale up that environment, scale down. They have very different requirements, okay, for those two, and so we have differing architectures. Both of them work well for us on Azure to provide high availability. Jayan's going to cover Adobe Experience Manager, and then after that, I will cover Adobe Sign, and then we'll talk a little bit about some of the takeaways. What are our experiences, lessons learned for people who were kind of coming into this and trying to deploy production solutions on Adobe? What are the lessons learned? What are the things we wish we had known when we started?
All right, thanks,
Yeah.
Dave. So Adobe Experience Manager has a fairly straightforward use case for availability zones. But before I get into the detail, I wanted to give you some context of AEM. So AEM is Adobe's leading web content management, digital asset management, and forms management solution. Very popular with customers, popular with critics as well, Gartner, Forrester. So it's got two distinct workloads. There's a content authoring workload, and then there's a content delivery workload. It kind of explains what they do. But the content delivery workload, which consists of two tiers, there's a publisher tier for the content, and there's the dispatcher tier for caching that content. Together, that particular workload lends itself pretty nicely to be scaled out horizontally across multiple availability zones. In terms of the technology stack, we are exclusively Red Hat Enterprise Linux. AEM is a Java application. We use an OSGI runtime called Apache Felix. And the dispatcher is essentially Red Hat Enterprise Linux with our own caching proxy module running in it. We've been running AEM workloads in Azure now for over a year. We got about 30 plus customers. We run about 500 plus VMs, mostly DS V2s. About 1,000 managed disks. We like managed disks because they let us take snapshot backups, which is really fast, really quick. We're active in about 10 Azure regions, including Azure Germany. Some of you might know that's a different beast. And the most popular region we have today is West US2, and the next one is West Europe. We have 3 distinct SKUs in terms of how we sell our managed service. It's based on application availability SLAs. So as you can see, the second and the third one requires multiple availability zones. The thing to note here is that those SLAs are what Adobe offers to our customers, not what we get from Microsoft for a particular Azure service. So this is our 3.9 SLA offering, SKU. It is a regional solution. So the key here is the zone redundant application gateway. It's fairly new. It has a presence in each zone, and it's resilient to a zone failure. It's a layer 7. For those of you who don't know what an application gateway is, it's a layer 7 HTTP-aware load balancing service that has some features that we really like, 3 of them especially. SSL offload, the ability to do URL-based request routing, and the third option is the fact that if we needed to, we could enable web application firewall on it for those customers we have who might be a little prone than usual to DDoS attacks. As you can see, we have pairs of published dispatcher pairs across the different availability zones. Even though I show only 1 pair per zone, we could easily deploy 3, 4, 6 pairs per zone if the customer's request load demanded it. On to our global solution, multi-region, multi-AZ solution. The key service here is the Traffic Manager service, which is a DNS-based global load balancing solution. Even though it looks like in the picture that we are doing 2 levels of load balancing here, the thing to note is that for a given particular user, that user goes to the Traffic Manager just once during the session, gets the IP address of the nearest application gateway, and after that, the connection happens between the user and the application gateway with the Traffic Manager out of the picture. The newly announced front door service, we are very excited about that. It looks like it has all the features we might need to kind of one day replace Traffic Manager with it. It looks very good. Before I hand it back to Dave, just a couple of words about health checks. This is one of the biggest lessons learned for us during our testing, the importance of health checks. So the typical day job of a load balancer is essentially load balancing, but there's a couple of other things which are critical that they do, which is the detection of an application failure, and just as importantly, the detection of an application recovery, so that it can act on it. And how well and how quickly the load balancer does its job depends a lot on the quality of your health check. So you really need a health check that is application aware, that is smart, that is deep, and does its job well. Simplistic health checks such as TCP pings or loading a web page and looking for a 200 OK response are probably good enough for the Traffic Manager, but not for the application gateway. So with that, Dave's now going to talk to you about Adobe Sign.
So with Adobe Experience Manager, the model's fairly simple. They have some fairly static components. They take care of distributing the content across availability zones. And so they were able to adopt that very quickly and in a very simple model be able to get the kind of availability they want using availability zones. Adobe Sign is the multi-tenant solution. So what is Adobe Sign? Adobe Sign is Adobe's e-signature solution. You use that instead of paper and ink kind of processes to sign documents. Adobe Sign is used by large enterprises to sign sales orders and deals like that you know at the end of a quarter or at the end of a year, that's really, really critical. You can have millions of dollars going through that system that cannot go down. It's got to be available. It's absolutely critical. Now, the components that are used to deliver that solution or that service, there are about 20 different components that are used together that we run in VM scale sets. Now, you'll notice that Ziv mentioned that there's zonal scale sets where I can create one that's in just one AZ, right, dedicated, or you can create them where they can spread across availability zones. Each of these, so we've got things like the Web and Apache tier, I'll show you a drawing of, task workers for virus scanning, PDF conversions, rasterizing, and then even the part that's actually doing the signing, getting the keys, signing the documents, MySQL database layer. All these are VM scale sets, and there's about 20 of them that we use for this particular solution. Now, if we look at just a simple model, a simple view of this architecture, and we repeat it over and over again for all those VM scale sets, you'll notice we have a region with, in this case, 3 availability zones, zone redundant. This is a standard load balancer configured for zone redundancy. And that fronts a web server using Apache, HTTP. And this is a VM scale set, again, that is striping the VMs across all 3 availability zones. And then behind that, we've got an app server tier using Apache Tomcat. And then behind that, we've got a MySQL database. Now, in our case, we're using Tungsten. This is running on VMs. And so Tungsten takes care of the replication. It takes care of things like quorum, determining who the master is, among the 3 different instances of the master and slave virtual machines running MySQL. And then behind that, we also have the zone redundant storage. And with zone redundant storage, all of the VM scale sets talk the logs or a number of other things that they may be writing to the zone redundant storage, which includes storing of the documents that are being processed and worked on go into that zone redundant storage. And as Ziv mentioned, with zone redundant storage, it's a synchronous write to putting at least 1 copy in each of the 3 availability zones. So what does that look like from a customer experience? So a customer makes a DNS call, gets a name resolution to the zone redundant load balancer. That does the traffic distribution across the 3 zones to the VMs in the VM scale set for the web server that reside in those zones. And then those Apache web servers, they're configured to distribute the load across all the VMs in the VM scale set across the 3 zones for the app server tier. And then Tungsten takes care of the intelligence for determining which of the 3 instances of MySQL are the master for read-write and which ones are there for read. So read can be in the local copy, the local database, and write's going to the master, in this case, zone 3. Okay? So let's look at a failure process, simplified. Okay, what does that look like? So let's simulate zone 3 going down. That's where the master was for MySQL. So one of the first things that happens is Tungsten does its quorum negotiation and decides, okay, the database instance in zone 2 is now the master and is pushing replication to the slave in zone 1. Anything that's being written to storage now is just writing to the 2 replicas, one in zone 1 and one in zone 2 in a synchronous manner. One thing to note, that's a quorum required thing, so for storage, you always have to have at least 2 availability zones. If you ever lost 2 zones, then your storage is not available. Okay, so what does that look like from a user interaction standpoint? Again, you're doing name resolution, pointing at the standard load balancer. It's done health check and is just distributing load to those web servers that are available in the AZ1 and AZ2 for that scale set. Still continuing the same thing, health checks going from the app servers down to, the web servers to the app servers. So it's now only sending traffic to zone 1 and zone 2. And you can see now Tungsten's negotiated to send all the write traffic to the database instance in zone 2 and can send read traffic to either one, zone 1 or zone 2. Okay, so the other thing to note is, you'll notice I brought up a couple other instances for the app server and the web server tier. Today, VM scale sets support the ability to use auto-scale metrics. So for example, if you wanted to scale up your load when you lose a zone, you can use auto-scaling metrics like CPU, memory utilization, so forth, and you can scale up based upon load. So what are the takeaways? That was just our simple architecture, and we're finding that simple architecture works using those components. And it's a very different architecture for Adobe Sign than it is for Adobe Experience Manager. Both of them are working well for us. Well, what have we learned? First of all, like Ziv mentioned, do your homework. Make sure you know what regions you're trying to target and what Azure services you're trying to use. Do your homework to make sure that those services and those regions support availability zones. And second, as JN mentioned, tune your health checks. So in our case, we played with TTLs a little bit and found the optimal settings for those for Traffic Manager. And then make sure your health checks are very as deep as you can make them that actually make sense for your application. Otherwise, for example, Microsoft invited us to take part in what they call a zone down drill, which they do for a new region. So France Central was coming online. Before France Central came online, Microsoft goes and will shut down a zone. They'll just power everything down in that zone to validate that all their services are working well through a down scenario. And they invited us to take part in that. And what we found is our stuff failed really well. What didn't work well is the recovery. Just like Ziv said, walk through it, make sure you understand. So our recovery didn't work well because the load balancer came up first, and the VMs came up, but the app wasn't ready. We didn't have deep enough health checks. And so we did really well at less than a minute, or just between 1 and 2 minutes, I think it was the stability time when we actually had a zone failure for AEM. But when it came back up, we had a much longer outage because we were receiving traffic through the load balancer, sending it to app servers that weren't up and running yet. So we had more of a problem with that recovery. That's maybe one of our biggest takeaways from that is make sure you're testing recovery when, let's say, for example, a network partition event, recovers, or you say you had a down drill and that availability zone is coming back up. Make sure you deal with that recovery along with the failure. Things should be automated. So you don't have time for our SLAs. Everything has to be based upon automation, not upon people, or they just get too long. Especially when you have a down event, you're not always certain exactly how well that control plane is going to react. As everyone else is trying to adjust to it, you want to make sure that you are set up so that everything recovers automatically. In the case of scale, when you have a down event, let's say, for example, we had a South Central. If South Central was an AZ and you lose that data center where that AZ is, in our case, for Sign, we are statically over-provisioning. There's a couple of technical reasons why we have to do that, and that was before we had the ability to do some of the auto-scale capabilities. So we're statically over-provisioning. Let's say we wanted to always have 6 VMs available. We'll provision 9 across those 3. So always either over-provision or use the auto-scaling rules to be able to scale up based upon load. And lastly, Ziv mentioned ZRS. So there are cases where you might want high availability with zone redundant storage. With ZRS, you have synchronous replication, 3 copies across the 3 AZs in a region. And you may also want that data copied to another region for data durability reasons. Or data recovery reasons using GRS or RAGRS. Today, those two are independent. I can pick ZRS or I can pick GRS or RAGRS. So today, if you need that, you'll need to write twice. One to an RAGRS storage account that replicates to another region, and one to ZRS that is synchronously writing to the 3 availability zones within your region. That's something that we're always having conversations about, something we're looking for, having support for both of those in one configuration. But that's the way it is today. And it's just a heads up, something we didn't think about as we were kind of going into that. So those are some of the lessons learned and experience and architectures that we've been using to provide production workloads. And with that, back to our fearless leaders.
Thank you so much. Thanks for presenting. Adobe gave us an excellent example on how it should work. Thank you.
Thank you.
Yep, you're welcome.
Just 3 points before the music. Just 3 points. I'll be super quick. Point number 1, fast track for Azure. This is essentially a support experience for building the solutions. There is a link here. You can fill in your details and fill in some questionnaire, and in many cases we will come forward and offer you help in designing your solution. Number 2, please fill in the feedback for this session. We will be happy to hear what we should do different and how we can improve. And number 3, there is nothing else I can tell you that should stand between you and the theme park right now, Universal Studios. Go for it. Thank you for coming.